Remember, guys, everything is nuclear fusion or fission or quantum mechanics, at least inside here. So I want to just show you here, real quickly what this is in context relationship to as far as this video. Let's see if we get her going here. Come on. Okay, so this is about Iranian chips that are only U.S. patent designs or U.S. manufactured. And so what I wanted to note here is, listen very carefully.
If you look back at the MAX 232 datasheet, it shows that it will typically generate
you need these manuals. Why?
Something like 7 volts or negative 7 volts.
Because that's an important number. It may not be those numbers when it's going through whatever chip.
And it guarantees a minimum of at least 5 volts for the positive voltage, or at least as negative as.
But it has to be up or down in charges like that.
So it does indeed meet or exceed
now, what does that
in NP?
Spec? Back to what equipment you're doing, you might need a breadboard factory or a thing, and cut them a commission for how much you make, not just the patent and buying it up like this. It's a charge pump thing, which we're going to get into here in a second.
For a negative voltage is below, typically 1.2 volts or.
So basically, that's what it's telling you. It's telling you in certain chips, X, Y, and Z.
Postal's law. After John Postal, who was involved in creating a lot of the early internet
momentum equations.
And in the original protocol for spec for TCP, he lays out this robustness principle that says that implementation should follow a general principle of robustness. Be conservative in what you do. Be liberal in what you accept from others.
And that'll be important. Okay. He's going to show you a chart here in a second.
And so that's what's going on here.
This thing.
The spec says plus or minus 3 volts. Anything above 3 volts is considered high. Anything below minus 3 volts is considered low. Anything between is undefined by the spec. Well, when it's transmitting, the MAX 232 guarantees at least plus or minus 5 volts. So it's being conservative, staying well outside this undefined area here in the middle. But when it's receiving, it considers anything above 2.4 volts to be high and anything below 0.8 volts
you can see
to be
the
low,
thing,
which makes it very liberal in what it
conservative
accepts.
on the
and it's generally considered to be a good engineering practice to be
it's
conservative
like I'll take money any which way, or I'll get it from any which way I want.
And liberal in what you accept, allowing things.
And what I let out, I'm usually a little bit more tolerant on because I let out.
But this can be gamed. There are bad RS-232 implementations out there that take advantage of this. They figure that, well, if other implementations are liberal in what they accept like this, well, then maybe we can get away with 5 volts being considered high.
And you see, I don't need that chip anymore. I don't need it to be in that exact
even
form.
Though that's not what the spec allows.
Even though the spec
so you end up with cheap products out there
especially in
that
a
sort of work a lot of the time, but aren't really all that reliable
highly enriched. If there's no bells and whistles, if it's not some China chip from in a Harbor Freight drill that has extra parts to it, I just need what it is in a cheap enough price to put it in there and then make it work. Its crib life works the same way, has the same lengths, but there might be a geometry thing in the housing of it. And so that geometry may not be just a Ryobi drill, you know what I'm talking about? It's this overhead angling angle of the building and what some of these MOSs are doing, what's going on out here in the power source too, because those things are also connected. It's much more complicated than that, but I'm hopefully that gives you a good visual of why QED and supersymmetry and those other things apply to why it's calculus or these multi-domain battlefields. We have no clue as what you want it to do yet. It's not designed to hello world this card, but that's what you can make it do.